Hello everybody and welcome to the third video in this Blockchain for Beginners tutorial series. In this video, I'm going to be giving you an introduction to Solidity and showing you how to write and deploy your first smart contract. This is really cool. I had a lot of fun messing with this before the video, and I think you guys are going to be amazed at how simple it is to actually write a smart contract. Anyways, I should mention that Solidity is the programming language typically used for deploying smart contracts and writing Ethereum smart contracts, and so that's why we're going to be using it. Now, in terms of kind of some prerequisites for this video, I'm going to assume that you have some understanding of programming, some experience writing in maybe a different programming language, just because in this video, I'm not going to explain the very basics like things like variables, functions, and all that stuff that's kind of common knowledge when it comes to programming. Of course, I'll go through the Solidity syntax, and we're really going to learn by actually just doing a bunch of examples and not focusing a ton on theory. Last thing I will say is that you do need to have your MetaMask set up if you want to deploy this to a test network, so an Ethereum test network. If you don't have MetaMask set up, that's fine. You just won't be able to follow along with that step in the video. All right, so with that said, we're just about ready to get started. I just want to quickly thank Cartesi again for sponsoring this video and this series. They're an awesome company, again, dedicated to making the blockchain more accessible and easy to use. They've really helped me a ton in terms of coming up with the content for these videos. Well, I hope you guys appreciate that. In the future videos in this series, we're going to be talking about how we can actually use Cartesi to fix some of the scalability issues with smart contracts, because you're going to start to see some of the problems that can actually occur when we write a smart contract, because they're a lot different than your traditional code. Anyways, let's go ahead and get into the code. All right, so I'm here on my computer, and the first thing I'm going to discuss is just setting up our environment for writing code in Solidity and deploying smart contracts. Now, of course, you can write contracts in VS Code or any local code editor, but instead for this series, I'm going to use an online IDE called Remix. Now, this is a browser-based IDE. It's completely free, and it's super beginner friendly and allows you to actually deploy and test your smart contracts directly from the browser. So I'd recommend that you use this. You can check it out from the link in the description, or just Google Remix IDE. Again, completely free, and once you click on that link, it should bring you to a page that looks like this. So for now, what I'm going to do is just give a quick tour of Remix. Then we'll talk about smart contracts, what they actually are, how they work. Then we'll start writing some code and going through some examples of smart contracts. So the first thing we want to do here when we open up Remix is we just want to install a few extensions specifically for Solidity. So you can write other stuff in Remix, not just Solidity code. So that's why we want these extensions. So what we're going to do is just on the left-hand side here, go to this plugin manager. It looks like a plug. And what we're going to do is search for Solidity. Now, for me, I already have these extensions installed, but what you're going to want to install is the Solidity compiler, the Solidity static analysis, and then the Solidity unit testing. Now, you don't really need the unit testing, but you might as well just install it while we're here. So install those three plugins, and once you have them installed, we're pretty much ready to start writing Solidity code. Now, you're going to see in the left-hand side here, let me zoom in a little bit, that we have a bunch of, folders, directories, and inside of here, we have some different smart contracts, we have some scripts, we have all of this kind of stuff. You don't need to worry about any of that. This is all just kind of test code that's provided to you. We're not going to use any of this. We don't even need to look at it. So you can kind of just ignore it for now. What I'm actually going to do to get started is I'm just going to make a new file. So I'm going to click on this little file icon right here. And then I'm just going to call this test.sol. So .sol is the extension for a Solidity file. So that's why we're going to use that. When I do that, it will open up a brand new file. Notice we have the little Solidity icon. Now we can start actually writing a smart contract. Now, one thing to notice here is there's stuff like GitHub integrations. You can create new directories. You can upload files. You can also have different workspaces. So right now I'm in a workspace I created called tutorial, but you also could make a new one by clicking this right here. I guess this is renaming a workspace. And then of course you can delete it. I'll let you look at that yourself. Pretty straightforward. Anyways, all we need to do is get to kind of a file that looks like this, just an empty Solidity file. So I'm just going to zoom in by clicking this plus icon here so you guys can actually read the code. All right, so now that we're here, we might as well write a very basic smart contract. I'll briefly show you how it works and how we can run it. Then I'll actually discuss smart contracts in detail. So how they work, how you call them, and how they're different from traditional code, because they are much different than anything you would have seen before. Okay, so what I'm going to do is zoom in a bit, and let's start by writing what's known as our pragma line. Now, the pragma line is required at the beginning of all of your Solidity files, and what this does is actually tell Solidity what compiler version this file needs to use. So there's a ton of different compilers that are accessible for Solidity. You just need to define the minimum compiler version. So I'm going to say pragma Solidity, and I'm going to say 0.8.10, and then put a semicolon like that. So for all of your lines, you're going to have semicolons at the end, very similar to something like Java. Okay, so we have our pragma line, again, just pragma Solidity, and then the minimum compiler version. If you want to see the compiler versions, you can go to, I believe it's this tab right here, and it will show you all of the compiler versions. So notice we're on 0.8.10, so I'm just using one of the latest versions that we have. Okay, and then for language, of course, that'd be Solidity, and you're just going to have compiler default. Now here, you can actually manually compile your Solidity code. I'll talk about that in a few minutes. For now, though, let's continue writing the rest of our contract. So after we do our pragma line, the next thing we need to do is define a contract. So I'm going to say contract, and then I'm going to give this a name. Now I can give this whatever name I want. I'm just going to call it my contract. So what I've just done is created a smart contract, okay? That's all you need to do. You write the word contract, give some name. The casing you're supposed to use for this name is Pascal case, which means you're supposed to have capital letters for every single word. And then inside of here, we can start defining some variables, some functions, and methods. Sorry, not functions, methods is what I mean. Anyways, for now, I'm just going to define a very basic variable. Then I'm going to show you how we actually deploy and test this smart contract. And then we'll continue with some theory and looking at this more in depth. So for now, what I'm going to say is uint. This stands for unsigned integer. And I'm just going to say that this is public, like this. I'm going to call this x, and I'm just going to make this equal to 21. Okay, super straightforward. This is just me defining a variable. The type of the variable is an unsigned integer. It is public, meaning anyone can view it. Its name is x, and its value is 21. So now that we have this contract, what we need to do is compile the contract and then deploy it. So all of our contracts in Solidity need to be compiled into bytecode. This bytecode is then sent to the Ethereum network where the contract is deployed, and then we can call the contract. So let's just look at a quick example of doing this. So we can manually compile by pressing compile. We actually don't need to manually do this. When we deploy, it will automatically compile for us. Anyways, I've compiled the contract right here. Notice I have my compiler version, Solidity compiler default. Then what I'm going to do is go to this tab right here. So just below it, let's see what this one's called, deploy and run transactions. And here, what we can do is choose a few different options for actually deploying our contract. So if you go here, notice we have a bunch of options. We have Web3 provider, injected Web3, JavaScript VM, and then we have the Berlin version of the JavaScript VM. Now, the JavaScript VM is what I'm going to use for right now, but what this is a virtual machine that simulates the Ethereum network in your browser. So this means you don't actually have to make any real transactions. You're not actually adding this to a legitimate blockchain. You're just simulating it so that you can test this directly in your browser. Now, if you refresh your browser, what's going to happen is anything that you've been simulating in the JavaScript VM is going to disappear because, well, it was being stored in, I guess, the cache or whatever inside of your browser. Point is, JavaScript VM is kind of a testing environment, and when you're actually going to deploy this smart contract for other people to use, you need to deploy it to what's known as a Web3 provider or an injected Web3. Now, injected Web3 is actually going to use whatever network your MetaMask is on. So if I do this, what's going to happen is when I try to deploy this contract, it's going to open up MetaMask, and it's going to require that I actually do a transaction to deploy this contract. Again, we're going to look at that in a second. For now, I just want to quickly show you deploying it and running it, and then we'll get into the theory. So I'm going to go to JavaScript VM, and notice here that when I do this, it's going to give me a bunch of different accounts that have 100 Ethereum. Again, this is just testing, and the point of these different accounts is that I can actually use all of them with my smart contract. Because every time I deploy the smart contract, I want to call a function on the smart contract. I need to make a transaction to do that, and that requires an account to make the transaction with. So for now, I'll just select this first account. I could copy the address here if I wanted to do that. The gas limit, just leave this the same for now. And then you could pick an amount of Ethereum that you actually want to send with this transaction. Now, I don't want to do that for now. I don't want to send any Ethereum. All I want to do is deploy my smart contract. So I'm just going to click on deploy, and then you're going to see down here, it's going to show you my deployed contracts. So I now have a contract. Notice it's showing me this little button X. And if I click on this, it gives me the value of X, okay? Very, very simple. That's all you need to do to deploy a smart contract. We'll talk about this more in a second. What I want to do now is hop over to my drawing tablet and start talking about some of the theory behind smart contracts and how they actually work and why we kind of needed to go through this. All right, so I'm here on the drawing tablet, and I want to start by discussing how we deploy a smart contract. Then I want to talk about their use cases and go through a few properties of them. So as we saw, we had a smart contract, and we stored this inside of a .sol file. Now this is our Solidity file, and this is what we refer to as our source code. Now the source code is simply the code that we write as a programmer. It's the closest to English. It's the easiest for us to understand. It is the source code, okay? This is where we actually write Solidity code. However, this code cannot be executed on the Ethereum network. So what we need to do is compile this by running it through a compiler into something called bytecode. So the first step when we're deploying this contract is we run this through a compiler. This compiler is capable of taking one language and translating it into another. And what we get here is now what I'm going to refer to as the bytecode. Now, the bytecode is just a special type of code that the computer can actually understand and execute. And in almost every programming language, what's occurring is you're taking source code, you're compiling it into bytecode, and then that bytecode is being interpreted by an interpreter. The interpreter you can kind of think of as a mini computer in a sense that's actually going to be able to take all of this code, read it, understand it, and then tell the CPU of your computer how to execute it. The interpreter is typically known as a virtual machine. Anyways, you don't need to know too much about that. Point being, you take source code, compile it into something like bytecode. Bytecode is then something that the computer can actually understand and execute, and so that's how your code actually ends up running. Anyways, at this point, we now have our bytecode. So we've taken our Solidity code, we've ran it through the compiler. By the way, Remix will do this for us automatically, so you don't need to manually compile the code. And now we have our bytecode. So let me just move my bytecode over here. So now that we have this bytecode, this is the code the Ethereum network can understand and that computers can execute. But how do I actually get this now to the blockchain? Well, what I need to do is I need to create a transaction. Now, I just want to quickly mention here that what a smart contract is just code that's sitting on the blockchain. So all we're doing is we're taking this bytecode, we're putting this in a transaction, and then this transaction is kind of special in the sense that it requests to create this code, this smart contract on the Ethereum network. So what happens is we make a transaction, we throw the bytecode on this transaction, we pay some fees, and then we kind of upload this or send this in a way to the Ethereum network, okay? So just like sending money between different accounts, except in this case, we're making a transaction that is adding this bytecode as a smart contract to the Ethereum network. Now, like all other transactions, the first thing that needs to happen here is this transaction needs to be associated with a block, then it needs to be mined. Once it's mined, then it is on the Ethereum network. Now, what that means is just like any other transaction, anyone can go and see this. They can see the transaction. They can see who created the smart contract. They can see all of the code of the smart contract. They're able to view when you created it, the balance of the smart contract, all of these other things. And this also means that once we add this smart contract to the network, we can never change it. We cannot mutate it. We cannot modify it. We cannot change it or delete it. And the reason for that is the same reason that we can't delete transactions on the Ethereum network, right? Because that's the way the blockchain works. It is forever there. It is a ledger of everything that has happened. It is completely transparent and trustworthy. And that's actually the main point of our smart contracts. So hopefully that makes a bit of sense. We're going to continue to clarify this in this section. Point being is that the reason we create smart contracts is because we're taking advantage of the security features of the blockchain to make people trust the code that we are uploading. So let's take an example where we want to write some type of poker application or a casino or something that involves money, right? Something that's going to have money being transacted from either us to the client or from the client to us. Well, if someone comes to our website or we go to some casino website, for example, most times we can't see the code, right? We have no idea what's actually happening in the back end. We could easily be getting ripped off. Maybe our money's being stolen. Maybe the odds are not in our favor or less in our favor than they should be. Whatever. If we can't see the code, we don't really have any way to trust what this website is doing or how these transactions are occurring. However, if you had your code as a smart contract and you knew that the website was using the smart contract, maybe you're able to verify that in some way, then you could just go and read the smart contracts that were being used and decide if you want to interact with them or not. This means you can fully and transparently see all of the code that's actually being ran and executed. You know if you want to trust it or not, and then you can decide if you want to interact with it, right? So hopefully that makes sense. One important point there as well is that that code that you're looking at can never be changed, which means if you're interacting with the same smart contract, you know it's always going to look like that and it's always going to be trustworthy. So that's kind of the main point of smart contracts, is to allow people to trust the code, to make it fully visible to everyone, and also just to allow everyone to be able to use it, right? Although I will say it is pretty expensive to be interacting with smart contracts and uploading them to Ethereum. Okay, that is the main point of smart contracts. Now, one thing I'll mention as well is that smart contracts can have a balance. So that means you can send money to a smart contract, it can receive money, it can send money back to you, it can call other smart contracts. And in fact, we're going to start talking about that now. So let me clear the screen, and now we're going to talk about how you actually call a smart contract. So in front of me, I have a beautiful illustration. I have a contract and 2 Ethereum accounts. Now, as I said briefly, a contract can have a balance. So just like an account, a contract is going to have an address, it's going to have some type of balance, so it can actually store Ethereum, and it can send and receive Ethereum as well. So that means that the account 2 can send money directly to the contract can send money back to it, and again, account 1 and account 2 I'm just treating as regular Ethereum accounts, so ones we already would have talked about. Anyways, the contract has a balance, and that means we can go and view the balance. We can see every single call and transaction that's happened with the contract. Everything is completely transparent, just like our other regular Ethereum accounts. Great. Okay, so now that we understand that, I want to talk about the fact that a contract should really be treated like a state machine. So what I mean by that is that most contracts are going to store some type of data. So in this case, we have x equals 1. Now we need to think of this like the state of the contract. And the reason for that is that these contracts are not constantly running. They're not just always executing in the background. They need to manually be triggered from a transaction to actually do something. And so when they're not being called by a transaction, they're simply some state that's sitting on the Ethereum blockchain, okay? That's all they are. We just have the code, we have the values of the different variables, so the state of the contract, and we can access the state or request to change the state by making some type of transaction. Okay, so let's see now how we actually call a smart contract, because I keep saying this, for it to do anything, we need to call it. So calling a smart contract is really just making a transaction that requests some operation be performed on the contract, okay? So from account 2, maybe we make a transaction. So in fact, let's just write TX here representing transaction, and this transaction is going to the smart contract. Now, usually what we do is we pick some type of method or some operation we're going to be performing on the contract. So maybe we call some method here like setX, and we pass value 2. Now, the smart contract can do whatever it wants in this method, but maybe all it does is just change the state to 2. Then what we would do is we would simply change this. So now x is equal to 2. Perfect. Now, when we make this transaction, just like any other transactions, we need to sign it, we need to secure it. We're going to have a to address and a from address, and we're also going to have to pay a transaction fee, which is going to be made up of gas. Now, you can think of gas kind of like a literal gas in the real world, in the sense that this contract requires gas to actually be able to execute code. So every single operation this is going to perform is going to use a tiny bit of gas, right? It's going to use a little bit of gas. And so we send what's known as a gas limit. So the maximum amount of gas that we potentially want to use in executing this contract. And then if that's enough gas, the contract will actually be able to execute. It will run through all of the code, whatever. It will have enough gas to do that. It costs us Ethereum essentially to execute code on the Ethereum blockchain. Okay, now the amount of gas you send in is required is going to depend on what the contract is doing. Some operations require a lot more gas than others. Anyways, that's pretty complicated. We don't need to talk about that for now, but just understand that what happens is we're passing along gas, and the gas allows the contract to actually execute. If it runs out of gas, just like a car, it's not able to do anything else. Okay, so that's it for calling contracts, but now let's quickly talk about contracts calling other contracts, because that is possible. So let's say I have another contract right here, and maybe this contract needs to interact with this one. Maybe it's going to call something on it, it's going to send Ethereum, whatever it's going to do. So first of all, that's fine. These contracts can interact with each other, but they can only do that if this interaction stems from, is at the root of some account sending a transaction. So these contracts, if they have no transaction, so imagine this guy's gone right here, they can't do anything. They cannot execute, they cannot call each other, they can't do anything at all. They're just sitting there idle. They are state machines. However, as soon as I have some transaction from any regular Ethereum account that goes to a contract, now this contract is capable of performing some operations, executing some code, whatever, and calling other contracts. It needs to start, though, from one of these main transactions. There's no way for this contract to call the other contract unless we start from a transaction that I've showed you right here. So all of this needs to kind of root from some transaction outside of the blockchain. So what I mean by that is from some kind of regular Ethereum account. So hopefully that makes sense. But again, you can really think about this in the sense that these contracts are idle, not doing anything unless they're called from outside of the main blockchain network, right? So from kind of a regular account. And so if no account is calling any of these contracts, they're not able to do anything. And we also need gas, which is going to be passed along with the transaction to the first contract call that we make. All right, so with that said, I think that ends the theory section of this video. I apologize if this was long, but this really did need to be covered. Now we're going to get back to the code, and I'm going to start showing you how to write more advanced smart contracts. All right, so I am back on the computer, and now what I'm going to show you how to do is how to deploy the smart contract to a real Ethereum network. So we'll go with the test network, right? Rather than the JavaScript VM, which is going to emulate the blockchain in your browser. So what I'm going to do here is change this to Injected Web3. Now, when you do that, it's going to connect with MetaMask, which I assume you already have set up, and it's going to show you the test network that you have, I guess, enabled in MetaMask and the account that you're using for MetaMask. So in this case, I have my tutorial account that has a little bit less than 1 Ether. Anyways, in the same way that we deployed this when we were using the JavaScript VM, we can just click deploy. It will automatically compile this for us. We don't need to manually compile. And then it's going to actually bring up MetaMask because we need to make a transaction to do this, right? We need to create the contract. That requires a transaction. So we can look at data. This is going to have the contract data. We're going to have our details, and it's going to tell us how much it costs. Now, the bigger the contract is, the more this would cost. Anyways, this is relatively cheap. I will click confirm. Okay, now this is going to take a second, and if I bring up this kind of, terminal here, console, you're going to see it tells me that it successfully deployed the contract, okay? So you can view kind of, I guess, the output of all of the transactions and contract calls by just bringing this terminal up right here. Anyways, what we're going to see now is it shows my deployed contracts, so this is my deployed contract. Now, what I want to do is actually look at this contract, so let's see how we can do that. So what I'm going to do is go to MetaMask here. I am going to go to the contract deployment, which is right here, okay? And then you'll see that I can actually click on this button and it will allow me to view the transaction on Etherscan. Now, I had some other transactions there. I was, of course, messing with this before the video, so you can ignore those ones. This is the one that we just created. Anyways, now we are in Etherscan, the Gorelli test network Etherscan, right? And we can see we had our transaction, it was successful, and we have the from and the to. Now, what I want to look at is the actual contract address. So I'm going to click on that right there. Now it's going to bring me to the contract address on Etherscan. So I can see the balance. I can see the content creator. So this was me, right? I created this contract at this transaction. And then it tells you that the content or the contract, was created. Now we can look at the contract itself. So we can actually view the bytecode. We can decompile that into the source code if we want. And then we have events. I'm not going to talk about that right now. That will be in the next video. Anyways, we can close that. I just wanted to, let's go back. I just wanted to show you what that looks like. Okay, so let's go back to Remix. All right, so now that we have this deployed, we can use the contract, right? So I can access the variable X. That's fine. It's going to give me the value 21. So one thing to note here is that when you're viewing the state of a contract, so we're just looking at the value of X here, right? Viewing the state, this is free. We don't need to do a transaction. It's fine. We can query the state. That's a free operation. And the reason for that is the state is available, right? Like we can go look at the state of the contract because it's stored in there, publicly available. It's already on the blockchain. So we don't need to do any computation. We're just querying and viewing a state. So that's completely free to do. So that's why when I click X here, I get this instantly and it gives me 21 because I don't need to actually have a transaction mined to view the state. The only transactions I need are when I'm modifying the state of this contract, okay? Or performing some type of computation. Anyways, what I want to do now is change the contract so we can actually update the value of X. So this is where we'll talk about functions/methods. So what I can do is inside of this contract, I can create a function. This will be a kind of a method associated with the contract. Obviously, I need to give this a name. So I'll give it something like setX. Now for the parameters of this function, I need to define first their type and then the name of the parameter. So I'm going to say uint underscore x like that. This will kind of be my new x value that I want to set x to. Then I need to give my access modifier for this function. Now the access modifiers essentially tell people trying to use the contract if this function is private, if it is public, if it's internal, external. I'll talk about what all of those mean, but you need one of these here. So I'm going to say public to define the fact that anyone can use this method. So a contract, anyone calling this from a transaction is able to use this method because it's public. Same with this variable x. Now, if we made x private, for example, you wouldn't be able to access the state of it, at least not very easily, because it would be private to the contract. Again, we'll talk about access modifiers in a second. For now, though, we'll just say function set x uint underscore x. We'll make this public. Then I'm just going to say x is equal to underscore x. Okay, so now when I call this function, we will change x, change the value, and then when we access it again, it will be different. Pretty straightforward. Okay, so now that we've changed the contract, we need to redeploy this. I'll do this again to the Gorelli test network, so I'll just click on deploy. Okay, we're going to have to confirm the transaction, and notice this time it's a bit more expensive. We have more content in our contract, and so it makes sense this is going to be more expensive, right? So I'm going to click confirm. Okay, it's going to take a second, and then once it's created, we should be able to use it, and I'll show you what happens when we actually modify x. Okay, so the contract has been created. I'm going to click right here, and now we'll have a new contract, so we'll look at that one in a second. But for now, what I can do is set x. So if I look at x right now, it's 21. That was free, right? I didn't have to pay for that. I'm just viewing the state. But now if I change the state to say 25, so let's set x, notice I need a transaction, okay? So it's giving me a transaction, and this is going to cost me a certain amount of gas, right? So I will click confirm. Now this is going to take a minute. I need to wait for the transaction to be mined. Okay, it was done pretty quickly. Now if I click X again, its new value is 25. So I've modified the state of this contract. Okay, hopefully that makes sense. That kind of wraps up all the explanation in terms of how you call a contract, what the state of the contract is, all of that stuff. Now we're going to continue looking at some more Solidity syntax. All right, so I've just cleared my code and changed the environment back to JavaScript VM. Now I'm going to talk to you about a few data types in Solidity. So the first one is uint. Now we've already looked at this. It stands for unsigned integer, meaning we can store any positive whole number, okay? So I can do something like uint public x is equal to 1. Of course, we know that is valid. Now with the uint, this actually allows us to specify the number of bytes we want to use to store the integer. So I could do something like uint 8, uint 16, uint 32, uint 64, uint 128, and then 256. And I believe 256 is actually the default. So if you just write uint, I think by default it uses 256. I'll put something on the screen that confirms that or not. Now let's actually just see what happens if we try to store a negative number inside of a uint, okay? So let me just deploy this contract here. We have our smart contract, and notice that it's actually not even deploying this, right? Because we would have seen the variable y because we have an error. So it's deploying the last contract, so the last one that we actually had compiled, not this one because we have the error and it's showing that right here, okay? We cannot implicitly convert -1 to an unsigned integer. Now, of course, though, we have regular integer, right? So a regular int allows us to store a signed number. Again, just like the uint, we can specify the number of bytes. So 16, 32, 64, whatever. Now let's run this one. So deploy, and let's see what we get here. And now we have y. So it actually deployed this contract and we can look at its value. Perfect. Okay, so that is int. Now, other than int, we have a Boolean. Okay, so we can say something like Boolean public y is equal to true. Let's deploy this. Now, oops, I want to close that. Let's look at this contract here. Click on y and notice we get true. Now, of course, other than true, we have false. I assume most of you know what the Boolean data type is. Just note here there is a lowercase on the first letter rather than a capital if you're coming from Python like me. Okay, so we had int, uint, bool. Now we also have address payable, and mapping, and a ton of other data types as well. Now I'm only going through these ones because these are kind of the core, most important ones we're going to use right now. There is strings, there is arrays, but those work really strangely in Solidity compared to other languages. So just be careful there if you're looking at, say, a string or an array. There's a lot of nuances and kind of details with those. Okay, for now though, let's actually not do a string. So let's actually just look at the mapping type. So the mapping type allows us to take some key and associate it with some value. So I'm going to say public, and then we'll just call this map, okay? Now, what this means is that I can have some data type for the key and some data type for the value. This is very similar to a dictionary or a hash table. So when I define a mapping, I need to pick the value for the key, or the type, sorry, for the key, and the type for the value. So for right now, I'm just going to say uint like that is associated with int. Now, just to show you how this works, what I can do if I want to set a new mapping is I can say map, and then I can put my key like this is equal to my value. So if this was a real example, I could do something like maybe the map of 1 is associated with the key of -2. Now that means if I accessed map at 1, it would give me -2, okay? So this allows you to associate some key with some value. Very useful. You're going to use this all the time. Anyways, that is a mapping. Again, you put the type of the key, and then you do this little equal and I guess greater than sign or less than sign associated with whatever the value data type is. So right now, what I'm going to do is just make a function that lets us actually add a new key value pair to this mapping. So I'm going to say function, we'll say set key like that. We're going to take in a uint key and we'll take in an int value. Okay, and then we're going to say that this is public. And inside of here, we'll just say the map at key is equal to value, okay? Now, since this function is actually going to be changing the state of this contract, that means we will require a transaction to use this, excuse me, but since we're in the JavaScript VM, we don't need to do that because we're not actually on the blockchain. Anyways, let me quickly go through the syntax. So function keyword, this lets us make a method or a function inside of the contract or inside of the class, whatever you want to call it. We then have set key. This is the name of that function. We have our parameters, key and value, and we're defining the type that is required for those. We then say this is public, meaning anyone can call it. And we say map key equals value, adding a new key value pair to our mapping. Okay, let's deploy this. Okay, so here's our contract. Let me open this up. So we have set key and map. Now, one thing to note is that automatically when you define a variable like this outside of a function, so just in the body of the contract, it's going to have a getter added for it automatically, which means I can access any value in the map. So I could do something like map1, and we're going to see its default value is 0. So in Solidity, all of our data types have a default value. So even though we didn't assign this to something, we just declare that it exists. If I try to access any key, since the value type is int, it's always going to give me 0 unless we have a different value for that. Okay, so let's just set a key. Let's set like 5 with, actually, let me do this. We'll set 5 with like -23. I'll click on transact. And now to test this, I'll see if the key 5 is associated with -23, and it is, so we're all good to go. Now let's do another one. Let's do like 4 with -10. Okay, transact. Let's go 4. And then notice we have -10. Perfect. There we go. Okay, so now that we have done that, what I want to do is talk about addresses and how we actually accept money in the contract as well as pay money out. So let's get rid of all of this for right now, and let's start making some functions that can receive money and send money. So what I'm going to do is write function. We're going to call this receive, and this is going to be an external, like this, payable function. Now let's talk about external because we haven't yet seen this. So just like the public keyword that we had, what external does is it makes it so that this can only be used from outside of the contract. So I cannot call this function from within the contract. If I did that, that would give me an error. And the reason for that is because we're going to be accepting some Ethereum. And when you define this as payable, which is what I've done right here, this means that we can actually pay money to this function when we call it, okay? Hopefully that makes a little bit of sense, but we're saying function, receive, external payable, meaning, okay, we can accept money and we can only accept money from outside of the contract. So we can't call this from within the contract. Whenever you're accepting money, you need to put payable. When I say money, I'm really talking about Ethereum. Anyways, inside of here, we actually don't need to do anything. We can just write the body of this function. In fact, that's completely fine. And now what I'm going to show you is that what we can do is send money to this contract by calling this receive method because it's external payable. So what I'm going to do is deploy this. Okay, when I deploy it, I'm going to have my contract down here, and we have this receive function. So when we click this red button here, what's actually going to happen is we're going to send this amount of whatever this unit is, so in this case, it's way, from this account to our contract, okay? So this function doesn't need any body. If it's external payable, that just means we can pay money to it. And so what I'm going to do here is set this to like, I don't know, we'll go with 10,000 way. Now, Wei is the smallest amount of Ethereum that you can send. I believe 10 to the 18 Wei makes 1 Ether. So this is a very small amount. Anyways, it's going to take it from this account. In fact, let's just send it from another account so that we can see if it actually worked. Let me make it a bit larger. And when I click the button again, it's going to send that amount from this account to the contract. So let's do that. And now notice this amount has gone down. I have sent some Wei, right? There you go. Makes sense. Now, there was also some gas associated with that. That's why it's not perfectly even. And the gas limit was right here. Okay, awesome. So we said function, receive, external payable. Now, this contract technically has a certain balance. It would be 10,000 Wei. All right, so now that we've looked at that, I'm going to show you how we can actually view the balance of this contract from a function. So I'm going to say function, and then this is going to be get balance. Okay, let's spell balance correctly. And then we don't actually need anything inside of parentheses. And what I can do is make this a public view that returns like this, a uint. And sorry, not unit. This is going to be a uint. And then we can actually write the body of our function. Now, let me just talk about this view keyword because we haven't seen this yet. View is saying that this is a read-only method or a read-only function, which means it cannot modify the state of our contract. So you need to add that when you're writing a function that's going to return a value that's not modifying the state, okay? That's what we're doing. So public view returns uint. Now inside of here, what I'm going to do is I'm going to simply return the address of this dot balance. Now, let me talk about this for a second. So return, pretty straightforward. We're returning a value from the function. Now, what address is doing is actually casting this, which is referring to the contract itself to an address. So this is the address type, right? We can use this to actually cast this, the contract, to the address. And then on the address type, we have balance. Balance is how much Ether is in this account, or in this case, in this contract. Now, previously, you could just write this dot balance. However, in the new version of Solidity, what you need to do is manually cast this to an address. So again, this is just giving us the address of the smart contract. We're then getting the balance and then returning it. Awesome. So let's deploy the contract and see if this works now. So I'm going to go here. I'm going to send some money to this contract. First, actually, I'll go get balance. When I run get balance, notice that we have 0, right? There's just 0 balance. And let's now send some money. So let's go from this account here and let's just send 1 Ether. Okay, so if I send 1 like that, let's click receive, click on get balance, and then notice it's going to give me the balance in Wei. Okay, if I wanted to convert that to Ether, I would need to divide it by 10 to the 18, Wei, or I guess I could just divide it by 1 Ether. Anyways, not super important. Point is that, there you go, that is how you get the balance. Okay, so now that we've looked at that, I want to talk to you about a few global keywords that we have access to in Solidity from our smart contract. So remember, whenever the smart contract is running, it's been initiated, whatever, it would have had to have been called from a transaction. So someone had to send the transaction, they had to call a specific function or method, and then maybe they sent some Ether along with that. So we actually have a way to access that information, like who sent the transaction. So what I'm going to do here is write a smart contract that keeps track of the last person to send it Ether. So I'm going to make a variable up here, and I'm going to say this is an address. Now, again, the address is just storing an Ethereum account address, right? Or the address for an Ethereum account. So that's the data type there. We have access to things like dot balance on an address. So I'm going to say address. This is going to be public. I'm going to say this is last sender. So let's go last sender like that. And for now, we'll just make this equal to nothing. Okay, so it'll have a default value. I believe the default address is just a bunch of zeros. Okay. Then inside of receive, I actually want to set this to be equal to whoever the last sender was. So I'm going to say last sender is equal to, and then this is where we talk about the global keyword message.sender. So message is something that you can use to access all of the information about the transaction that was used to call this contract. Now, other than message.sender, we also have access to message.value. Now, this is going to be the amount of Ethereum that was sent with the transaction. And we have access to message.gas as well. So the amount of gas, I believe, that's remaining with this transaction. Okay, so let's go and change this back to message.sender. And now we can actually use this smart contract and see if it keeps track of who sent the Ethereum. So I'm going to deploy this. Okay, so we should be deployed. Let's change to one of these fresh accounts and let's actually send 1 Ether in the receive here, okay? So I'm going to send that 1 Ethereum. Let's check the balance. Okay, now the balance, oh, sorry, this is wrong contract. I want to use this contract. Okay, let's send 1 Ether. Okay, so go receive. Now let's check the balance. Okay, so we have 1 Ether in here. And now if I go last sender, it gives me the address of the account that actually sent this Ethereum. So now let's change this to be, let's go with this account. Let's send 2 Ether. Okay, get the balance. We now have 3 Ethereum inside of here, and the last sender has now changed. Okay, there you go. That is how you keep track of the actual last sender of Ethereum. Now what I would like to do is I want to show you how to send Ethereum from the contract back to a different Ethereum account, okay? Because right now what's happening is we're sending Ethereum to the contract, but the contract's not sending anything back. Obviously, that's not ideal. We need a way to, pay people back from the contract. So let's do that. So what I'm going to do is write a function. I'm going to say function. This is going to be pay. This is going to be address, payable, ADDR, and then this is going to be public, like this, and then payable. Now let's just quickly go through this. So the reason I have the payable here is because whenever I want an address, or whenever I want to be able to send Ethereum to an address, I need to specify it as payable. So address payable is different than just regular address. This actually allows me now to send the money to this account. If I don't have payable, then I won't have access to the methods I need for this address to send the money to. So just make sure you put payable. Then we're going to have public payable. Now, since this function is going to be paying money out, it's payable. If you're going to be sending money or receiving money, you need payable. And then, of course, this is public, which we've already talked about. So inside of here, there's a few different ways that I can actually send Ethereum. Now, some are simpler than others. Unfortunately, though, there's a bunch that have kind of some issues with them and that are not recommended to use. So the ones you should not use are the following: ADDR.transfer. Okay, now I know I spelled that incorrectly, but you should not be using transfer. Okay, there's some problems with that. I'm not really going to get into them. And then we have .send. Again, there's some problems with this. Don't use this. Instead, what you need to use is the most complicated one, funny enough, which is going to be something like this. So let me just type it out, then I'll explain it. This is going to be bytes, memory, and then this is going to be data. And this is going to equal to ADDR.call. And then we're going to say here that the value is equal to, and whatever the amount of Ethereum is we want to send. And then we're going to call this with 1 argument. Okay, I believe this is correct. Let me move this over a bit so we have some more room. Okay, so function pay, address payable, ADDR, public payable, and then we have this kind of crazy line right here. So first of all, what this is going to do is it's going to decompose the return value of this into 2 variables. First, sent, and then second, bytes memory data. Now, this first one right here is going to be a Boolean variable telling us if this was successful. So if it was successful, this is going to be true. Otherwise, it's going to be false. There's a variety of reasons it could be unsuccessful. One of them being you don't have enough money in the contract to send. Okay, then we have bytes memory data. Now, this is going to give us the data of this transaction. Now, you don't really need to worry about this too much. In fact, I'm not really going to explain it, but memory is specifying that we want to store this data, which is a reference type in memory. Again, I'm not really going to talk about this much more. Just write this for now. We'll worry about this in a later video. Then what is this doing? So what we're doing is we're saying address.call, okay? And then inside of curly braces here, we're passing the value, which is the amount of Ethereum we want to send. Now, optionally, we can actually choose the amount of gas that we want to send as well. So forward with this transaction. You don't need to do that. You can just leave it to the default value, which is what I'm going to do. And then we call this whole thing with a string. Now, this is going to be the message that's going to be sent to our, to our transaction or with our transaction. So you don't really need to put anything here for right now. It just requires 1 mandatory argument. So that's why I put in empty string. Okay. Hopefully this makes a bit of sense. Again, address.call, curly braces with the amount of Ethereum that you want to send. And then this is setting up the transaction, and this is actually going to execute it when you do the kind of parenthesis call right here with the string argument. Anyways, what we can do after this is we can check if this was successful or not. And the way we do that is we could use an if statement. So ifs do exist in Solidity, right? I could do something like if sent, or I can use this fancy thing that we haven't seen yet called require. Now, what require does is similar to an assert statement because it's going to check the value of a condition or a variable. And if that's true, we're going to continue. Everything will be fine. If that's false, it's going to throw an exception and actually tell whoever called this smart contract that there was an issue with that call. So I'm going to say require sent, and then here I can put an error message. So I'll just say error sending money, okay? like that, or error sending, let's just go with F. Okay, so again, if this is true, all is good, we will continue. If this is false, then it's going to tell us that there was an error because we were unsuccessful in sending this Ethereum. All right, now let's add our semicolon, and what I can do is deploy this and test it out. Okay, so let's go back here, and let's deploy this. Let me close this contract. Okay, so we have our deployed contract. We have pay, receive, get balance, and last sender. So let us receive some money first. So let's send 1 Ether from this account. So let's go receive. Okay, last sender is this. Get balance is 1. Now let's copy this guy's address right here by clicking on copy. Let's paste it in here. Let's click on pay. And I think everything should be good. We can go back here now and we can see if we were paid the Ethereum or not. All right, so I thought something was going wrong until I realized that we actually are only sending 100 way here rather than an entire Ethereum, which is what I thought we were going to be sending. So what I'm going to do is change this to 1 Ether. Now, Ether is actually a built-in word or built-in keyword in Solidity, and it will just multiply this by 10 to the 18. So that will give me, I guess, 10 to the 18 way, right? So 1 Ether. Anyways, I'm going to change that to 1 Ether. So now this will pay 1 Ether from this function. Okay, so let me redeploy here, and let's close this. Okay, and now we have our contract. So let's receive some money. So let's go from this account. Let's just send like 5 Ether. Okay, so let's go receive. What's the balance? 5 Ether. Now let's copy one of these. Okay, and we'll pay it. And let's see if this is all good. I'll move up the console and looks like it's sent fine. Okay, so now let's go here and we should see that in one of these accounts we have, okay, almost 101 Ether, right? So I have 100.99999 because there was gas associated with the transaction. So we didn't get a full 1 Ether. We got a little bit less. Perfect. There you go. That is how you send money using, I guess, this right here, using this line. Okay, great. So now that we have that, what I want to do is I want to end by quickly writing kind of an example of a bank that allows people to send Ethereum to the smart contract and then withdraw up to the amount of money that they had sent to the contract. So if I send 1 Ether, I can withdraw up to 1 Ether from the contract. As soon as I try to withdraw more, it's going to tell me, hey, you don't have a sufficient balance. So kind of just like a very simple bank account. So let's go ahead and do that. All right, so let's get into this example of implementing kind of the basic bank accounts. So I'm actually just going to get rid of all of this. We can just rewrite it. This will be good practice. So I'm going to start by making a mapping, and this mapping is going to allow me to associate an amount of Ethereum with an address. So that way I'll know how much a specific account has sent so far, and so I can regulate how much they can withdraw. So what I'm going to do here is say mapping, and this is going to go address like that. And then this will go to an unsigned integer, which will be the amount of way that they have sent. So amount of Ethereum. Okay. Then I will call this balances. And I can actually manually make this private if I want. Now, when I make this private, what that means is there won't be a default getter for this. So I can't easily just access the balance of a specific account. Instead, I'll have to use one of the methods or functions that we define. Okay. Now we need some way to receive money. So let's write that. We're going to say function and we'll say deposit. Okay. And then this is going to be actually external and then payable. Okay. Now what I'm going to do is I'm going to say balances at, and then this will be message.sender, which is going to be the address of the sender of the transaction, is equal to, or sorry, plus equal to message.value. Okay, so remember all of the keys here are going to have a default value of 0. So even if this address doesn't kind of exist yet in the balances, it's going to have a value of 0 when I access it. So I'm going to add message.value, which is the amount of Ethereum they deposited. Okay, then of course, if this already existed, I would just be adding to it whatever the amount of Ethereum is they deposited in this transaction. That's all I need for here. I'm just adding this to the balances. Then what I'm going to do is say function withdraw. And this is going to need to take in an address to withdraw to. And in fact, I don't necessarily need to do that because what I could do is just use the message.sender address. So whoever was withdrawing, whoever sent the transaction, I just automatically give the money to them. But instead, what I'll do here is just put in an actual parameter so that you could technically withdraw your money to someone else's account. Hopefully that makes sense, but you'll see what I mean. So I'm going to say address, payable, and then this will be ADDR. and then we'll say this is going to be a public, and then this will be a payable function like that. Okay, so what I need to do here is I need to check that they have a sufficient balance in the balances before they can withdraw something. I also need to take in the amount that they're going to withdraw. So I'm going to say uint amount like that, and this will be the amount in way that they want to take it. Okay, so we'll say withdraw payable amount. Okay, great, that's fine. Now inside of here, what I'm going to do is I'm going to confirm that they have a sufficient balance before I let them withdraw. So I'm going to say require. And I'm going to say balances at ADDR is greater than or equal to the amount that they want to take out. Okay, perfect. So we'll do that. Then I'm actually going to send the Ethereum to them that they want to withdraw. So we are going to say, I guess this is going to be bool sent, and then this will be byte memory, and then what was this? Data is equal to, and then ADDR.call. And then this is going to be value colon amount. Okay. And then I think I can just call this like that. Okay. So that's good. Now that I have that, I'm going to confirm that they sent it successfully. So I'm going to say require sent, and we'll say could not withdraw. Okay. We got to spell this properly. This is just, okay, there we go. Could not withdraw. And then what I'm going to do here, after I successfully check if they withdrew or not, or after I check that they successfully withdrew, I'm going to subtract their balance. So I'm going to say balances, and then this is going to be at message.sender minus equals the amount. Okay, I think that should be good. Now let's just run through this and make sure we understand. So first, we're requiring that their balance is greater than the amount. So if the balance that they currently have in our kind of bank here is not greater than the amount, then we actually need to give them an error message, and we'll say insufficient funds like that, okay? I think that's how you spell insufficient. That should be fine, all right? And then what we're doing is we're trying to actually send this amount to them. So if they have a sufficient balance, we'll try to send it to them. If this for some reason does not work, then we'll tell them that they could not withdraw, and we'll keep the balance here, right? Because if we didn't send it, then the balance is not gone. We still have the money in the contract. Otherwise, we will subtract their balance, and then we're good to go. Okay, so now we have deposit and withdraw. And if we want to, we can write one more function here. Let's go function get balance, and this will just give us the balance of a contract. Okay, so let's just go public view returns uint. Okay, and then let's return the address of this dot balance, and that should be good. Okay, now we could also write something that allows us to get the balance of a specific address, or we could just make this public, but for now I'm going to leave it private. Okay, hopefully that is all good. Now what I'm going to do is just deploy this contract. So let's deploy it. Let me get rid of this one. Now what we can do is deposit some money. So let's go to this account. Let's deposit 10 Ether. Okay, so we're going to deposit. That should have happened successfully. Let's check the balance. Looks like we have 10 Ether. Now let's see if we can withdraw. So let me copy this address. Okay, so I'm going to paste that in there. In fact, let's make this larger. And for the amount, I wish I could copy this. Let's just go with a bunch of zeros here. I don't think I can write F directly in here, otherwise that would be useful. Okay, so let's click on transact, and let's look at our console here and see if this was good. Okay, it looks like we successfully sent the way. So now if we go, we see we have 85 Ether rather than 84, which is what we had before. So let me see if I can make this something like 5 now and click transact. Okay, it looks like that was successful. I guess we're not passing enough zeros. Okay, now we have 85.5999. Okay, now let me try to send an entire 5 Ethereum, which we know we don't have for this person. Actually, maybe we do, because I think we transacted 10 Ethereum. Sorry, but let's try this. Okay, transact, and that was successful. Now let's try this again. And notice that when I try to do it again, I don't have enough Ethereum for this balance, so I get insufficient funds as my error message. Okay, and if I look at the balance of here, we have 4.4 Ethereum left in the contract. So now let's try to do this from another account. So let me copy this address. And let's see what happens if I try to withdraw, say, 1 Ethereum from this address. Okay, if I do that, notice we get an error. It says insufficient funds because this address has not yet deposited any Ethereum. So let's now deposit some. So let's make this 1 Ether. Let's click deposit. Okay, now let's try to withdraw. And notice we were able to withdraw that successfully. All right, so that is all I have to show you for this example here. Hopefully that was a decent introduction to Solidity. I understand there was a lot of stuff covered in this video. I don't expect you to know all of it. I just wanted to kind of show you how to create a basic smart contract, how to send Ethereum, receive Ethereum, and then hopefully give you a bit of an idea behind the theory of how smart contracts actually work. In the next video, we're going to continue learning more about Solidity. I'm going to show you some more advanced things that we can do. And then in future videos, we'll talk about some of the limitations of Solidity and how to make things more affordable using Cartesi, which is a sponsor of this video and this series. Hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another one.